Hey, welcome everyone to SAS Explore. This is the Using Python for Data Analytics in SAS Viya. My name is Peter Styliadis, and I'm a Senior Technical Training Consultant at SAS. Let me tell you a little about myself. Again, I'm a Senior Technical Training Consultant at SAS on the Foundations team in the Education Division. My team focuses on course development and customer training. I spend a lot of my time assisting users with data analytics and data visualization using SAS, SQL, the CAS language, or CASL for short, SAS Visual Analytics, which is a point-and-click dashboarding tool, and then I do a lot of programming in SAS Viya to utilize the parallel processing environment, and I do a lot with Python natively and within SAS Viya. We'll start by executing this quick function to display the slides during the presentation. Now, before we begin with the demo, let me go over really what SAS Viya is and why you should learn about it. So let's begin with an overview of SAS Viya. Again, a very high-level overview. SAS Viya is the latest enhancement of SAS and is built for the entire analytics lifecycle, really no matter the job role, with a variety of tools that are either point and click or programming. Here it'll allow you to ask your business questions, explore, analyze your data, prepare your data, model, implement those models, act on insights, evaluate, and continue this process. This is done through a variety of applications that you can use in SAS Viya. SAS Drive is just the main page to find all your files. SAS Studio is the Integrative Development Environment, or IDE, where you can code in SAS, CASL, SQL. And there's actually a Python editor in some of the more recent releases where you can execute Python code within SAS Studio. And then there are a variety of other applications, more point-and-click tools like Visual Analytics for dashboarding, Data Studio for preparing your data, and then a variety of other tools like visual forecasting, data mining and machine learning, and visual statistics for those data scientists. So SAS Viya encompasses a variety of tools to really work with your data. Now let's look at kind of a high-level overview of the workings of SAS Viya here. So again, it's built for the entire analytics lifecycle. It's cloud native. It's scalable. It's what's called an in-memory analytics engine, which we'll get into in more detail here. And again, it's built for all users, any point-and-click users, programmers, anyone who needs to use a tool to analyze their data. Now, here's the biggest thing I want to get across. Especially if you're moving from maybe a SAS 9 environment to SAS Viya, SAS Viya contains two computing engines. First, the SAS Compute Server, or just traditional SAS, so the SAS 9 Workspace Server, as it's sometimes called. So SAS Viya contains that computing engine. So if you come from a work that has SAS 9 and you're moving to Viya, your SAS programs will still run as expected. But SAS Viya also contains another computing engine called the Cloud Analytic Services, or CAS engine for short, or CAS server for short. And this is a massively parallel processing engine for really your big data or resource intensive needs. SAS Viya is accessed through your browser, and you can use other languages like Python, Rest, Java, Lua, and R to access this environment. In here, we will be focusing on using the CAS server, so let's dive into it a little bit more. The CAS server in SAS Viya is the massively parallel processing environment. We will be connecting to the CAS server from our laptop using Jupyter Notebook and Python, and then connecting to the CAS server in the cloud. And this is known as like a CAS session or CAS connection. The CAS server typically has a controller node and multiple worker nodes. We will use this environment to process our data. Now, how do we use this? Well, just like you would with pandas and Python on your client, you would use pandas, the read_CSV method, for example, and you'd read a CSV file from disk into memory into a data frame. We're going to do something similar here. From our client, connected to the CAS server, we will load data from some data source that the CAS server is connected to, load it into memory on the CAS server. The CAS server will parse that data onto each worker node, so parts of the data will go onto each worker node and be loaded into memory into what's called a CAS table. So now this CAS table is distributed among the worker nodes. And now this is a typical serial load into memory. There are other ways to load data into memory, which we will not get into here, but I do have some resources at the bottom of this notebook. Once the data is loaded into memory, depending on how you loaded it, it could either persist in memory for days or weeks, or it could be what's called a temporary session table. Once you close out of the connection to CAS, the table will be cleared from memory. And that works similarly with pandas and data frames, right? Once you close out of Python, your data frames are released from memory. Now, here's some great features of when you load data into the CAS server. Anyone who has access to that location can now utilize or process that CAS table or that in-memory table. So person A is maybe using Python on the CAS server, person B is maybe using SAS, and person C is maybe using one of our applications like visual data mining and machine learning. They all are using that same CAS table, that same in-memory table that's distributed on this parallel processing environment. Whatever they're doing, their code will be sent to the controller. The controller will send those codes to each worker node. Each worker node will do its part, summarize the results, send it to the controller node, back to each individual client. So again, the data is processing in parallel, and since we can all access that in-memory table, we are minimizing input and output, data loading from disk into memory. Now, let's look at a big picture of ways to access data in the CAS server. So in the end, the CAS server is accessing data sources throughout your organization: databases, Hadoop, streaming data, path-based files, and data in the cloud. So the CAS server is connected to all this data throughout your organization. To process data in the CAS server, you need what's called a CAS action. And you can almost think of them as functions for the CAS server. These CAS actions, there's hundreds of them available. They can manage and prepare your data, analyze and model your data. They can even execute data step on the CAS server and SQL on the CAS server. And we'll look at a variety of those here. Now the question is, well, how do I execute an action? Well, there's a variety of ways to do that. One way is learning the CAS language, or CASL for short. And you can execute CASL code through SAS Studio in the CAS procedure. You can also use a variety of other languages like SAS, FedSQL, Java, Lua, R, Python, and REST API through the CAS API to execute actions behind the scenes. And again, we will see that here with Python. And then lastly, you can use any of the point-and-click applications who use data on the CAS server. And through the point-and-click tools, they'll be running actions behind the scenes. You typically won't see those, but there are ways that you can look at some of the logs if you are interested. So again, a variety of ways to process our data in this distributed environment. So what are we going to be doing here? Well, here we'll be using Python on our laptop with Jupyter Lab. And we will be sending commands to execute on the CAS server to process that data in parallel. From there, we have a variety of options. We can create new CAS tables, share them with other applications in SASVIA like Visual Analytics, which we'll actually do here. Or you can have these tables, prepare them, and then share them with your team. Another option is to really explore, analyze, and model your big data on the CAS server, and then bring back smaller summarized results to your client machine or to your laptop. Once you get those smaller summarized results, you can use familiar Python packages like Pandas and Matplotlib and Seaborn. So you're using them together. Now this is a question I always get, and I want to cover this early. So I have this distributed environment, so it's always faster. Well, no, it's not always faster. You have to start the services, right? So again, all this will be done behind the scenes for you, but services are being started, data is being loaded into memory and then sent to each worker node. On top of just doing that, there is some fault tolerance built in where it's building redundancies in your data. So if a worker node goes down, it can still execute your code. Monitoring needs to be taken on each of the worker nodes. Eventually, the results need to be collated or summarized, sent back to the controller, and then the controller eventually has to send them back to you. So there is some overhead here. So the next question is always, so when should I use this? All right, so when should I use this CAS server? Well, if you're using Python on your laptop, anytime your data source is larger than your client machine can handle, so on my laptop I have 16 gigabytes of RAM, so once I hit a certain level, right, loading that data frame into memory, it's going to take over all my RAM and my computer will probably shut down. So once your data source is larger than your client machine can handle, you want to start thinking about using CAS. And I know there's some other packages out there that you can look into, but in the end, if it's something larger than your client machine can handle, we're going to use the CAS server. Anything that's just computationally demanding that is maybe taking longer than you want, maybe try getting the data in the CAS server and processing it in parallel over there. The CAS server will be set up by your SAS administrator, and it'll already be accessing data throughout your organization. Right? I've logged into a VIA environment where I had almost 80 locations already connected. So all I needed to do was pull data and process the data, and it was already all connected for me. So if you have data in the CAS server and you want it, you can use the CAS server. If you need to use a specific CAS action, and we'll get into more details on why you'd want to do this, but if you need a specific CAS action, your data needs to be in CAS. And then if you're preparing data for another application, like maybe I want to prepare my data using Python, and then I want to create a dashboard using Visual Analytics, you'll need to get the data in the CAS server so Visual Analytics can create a dashboard. And we'll actually do that here. So now let's overview the swap package. And the swap package allows us to connect to the CAS server through our Python client. Now, the swap package blends the world of familiar Pandas APIs and CAS actions and CAS methods. So it blends the world together and allows us to connect to the CAS server to process our data in parallel. For example, within the swap package, I can use a familiar Pandas API method like .head. So I'll reference my CAS table, .head. Now what the CAS API is really going to do is take .head, convert it into an action, in this case table.fetch, and send that to the CAS server. Now I'm not going to see this. I can see this if I want, and I'll show you how to do that, but I traditionally don't care. I want to use .head, and I want 5 rows from my table. And this is exactly what this will do. But behind the scenes, it really will run an action. I just want to show you that. And then it'll send results back to you. Instead of using a familiar Pandas method in the swap package, you could just use the action itself and just, again, write it out as a method. CAS table.fetch, specify your parameters. The CAS API will just send fetch to the CAS server and then send you, again, the results back. Now, how are these actions organized? And these actions are organized in what's called an action set. So you can think of an action set as a package and actions as methods. Again, so an action set is just a package of actions. Right? So that's how it's set up. So the table action set has a variety of actions like CAS live info, table info, file info, and fetch. When we execute an action using Python, the action set name is optional, I'd say 97% of the time. But if an action name really collides with maybe a Pandas API method in the swap package, so there's the same name, the action set name is required. I don't think we run into any of those here, but just be aware of that. Now, some benefits of using a CAS action is, one, they're optimized for the CAS server. So they'll just get sent directly to the CAS server and processed in there. Some of these Pandas API methods that we'll use in the swap package will run 2, 3, 4, 5, 6 actions behind the scenes to mimic the results of Pandas. So they're just more efficient. A big one is if you have a team of data scientists or programmers and they all have different skill sets, like, hey, some know R, some know Python, some know SAS. If you all use actions, you can use the same action in any of those languages. So that's pretty cool. So if we use anything more advanced or any sort of data preparation or modeling action, if we all use the same one, we'll get equivalent results. And within actions, they are multi-purpose. So within an action, you have all these parameters that can filter the data, group the data, create new columns, etc. Now, this is a big misconception. So when we're using the swap package that connects to the CAS server, allows us to execute Pandas API methods that in the swap package. So they mimic what the Pandas methods do, but they're doing it differently behind the scenes. Now, if you use Pandas, Matplotlib, NumPy, and Seaborn, that does not execute on data in the CAS server. It just does not. It does not connect to the CAS server. It does not execute data there. So just be aware of that. However, when you bring data back from the CAS server to your client, to your laptop, they'll come back typically as data frames. And when you get the data frame back, you can use whatever you'd like on that. And we will do that here. And in the end, this is what I'll end my introduction with, is you want to use the best tool for the job, right? Sometimes your client and laptop is better, sometimes the CAS server. But in the end, use the best tool for the job, and these are a team. Sometimes I'll send commands to the CAS server, analyze, process my data over here, bring back smaller summarized results, and then use Matplotlib or Seaborn or Pandas on the summarized smaller results on my laptop. So we will do that throughout this presentation. We will use these as a team. Now, to get started with this demonstration, we're going to just do our setup. We'll import SWOT, we'll import NumPy, we'll import Pandas, we'll set some Pandas options. Again, this should be all pretty familiar to you. And then we'll import Matplotlib. And then we need to load the demonstration data to the CAS server. So I have some notes here for you. Here's a link to the SAS documentation page where the demonstration data lives. We're using small data for training purposes, right? It's small data. It's just for training purposes. In the code below, we'll go connect to the CAS server, go get the CSV file, and then upload it to the CAS server for us, and then save it as a CSV file over there. Now, if you are running this using your own environment, just be aware, and we'll talk more about this connection to the CAS server later, but I'm connecting to the CAS server using my credentials. Again, we'll talk about this later. You will need to modify this, and again, the rest should work accordingly. Some information about the data. This is what's Transportation Security Administration, or TSA data. The TSA is just an agency in the United States that has authority over the transportation systems like airports. So we will be using that data and claims that are filed for something like lost luggage, an issue, an injury, etc. Now, the data was pulled from these websites, combined and prepped for us. Now, the data is still pretty raw, so we will have to fix it, but there's some information for you. And it is between 2002 and 2017, or at least that's what it was indicated as. So let's connect to the CAS server. Now, when you connect to the CAS server, again, you take your laptop and you connect to the CAS server, most likely in the cloud somewhere. Once we make that connection, it's called a CAS session or CAS connection. I do want to point out you can create multiple independent sessions of each other and essentially execute code on each of those simultaneously. We won't be doing that here. It's a little bit more advanced, but that is a possibility. But we will create a single session or single connection to the CAS server, and that single session has its own properties, its timeout value, metrics, any action sets we've loaded, etc. So we'll create a single session. Now here's the key, and I sometimes find this the hardest part, is making a connection to the CAS server because, again, this is an enterprise environment, right? There's some authentication needed, there's some permissions needed, and there's some setup needed from the SAS administrator on your team. So just be aware of that. We won't go into those details here, but in the end, here is the address for the CAS server. In my training image here, it's a small demo training image. Here's the port number that was opened. And then here is my username and password. Be aware, you should never put your username and password in plain text. I am doing this here for demo purposes on this demo machine. But in the end, I connected using the swap package in the CAS method into a variable called con. And then if I view the value of con, it's connected successfully. My session name is called PySession1, and it has a unique session ID. So I am connected. And then if I view the type of my connection object, it's a SWOT CAS connection, so it's a CAS object. So I have a connection to the CAS server. I've taken my laptop, and I've connected to the CAS server wherever that lives. So I am connected. I'll run a quick action called about. So con.about is just an action. Right, and I'm just confirming that everything connected, and it tells me about the CAS server here if I want to learn more about it. Just some general information there, and then the node status. Just be aware, if you have multiple, if you have a controller and multiple workers, you will see all the workers here. Again, this is a small demo image, so we're actually running everything in parallel, but everything's just on a single machine. So now let's explore available data in the CAS server. So to connect to data in the CAS server, you need what's called a SAS Viya data connector. I've linked that in the notebook here if you would like to investigate further. But let's just look at really how to do that at a high level. In this example, I have a CAS server and I'm connected to 4 data sources. So one is called CAS user, one's public, one's HR, and one's marketing. These are called CAS libs, and a CAS lib provides a common interface into accessing different data sources throughout your organization. So for example, this CAS user CAS lib, that is your specific CAS lib for your username. So only you can access data in that location, and that's connected to some folder somewhere. You'll have a data source portion, again, that's connected to the folder, and then an in-memory portion for your in-memory tables. The public CAS lib is essentially anyone who has access to SAS Viya. So if your data is sensitive, you don't want to be throwing it in the public folder because anyone can access that location. And again, this is simply a folder path somewhere. Now, the HR data is connecting to some database that maybe only my team has access to. So there's 4 of us on the team, and we can access this database. So we only have access to this HR CAS lib, which is really pointing to this data source, some database. And then same thing, our team also has access to marketing data, which again is pointing to data, in this case, the cloud, and only our team has access to it. Each CAS lib has its own data source and in-memory portion. So let's take a look at a CAS lib. So I know there's a lot going on here, and let's just run through this. A CAS lib will have 2 portions, a data source portion, which are just the files on disk or in a database or in the cloud. So that's just pointing somewhere to some data source. The in-memory portion is the CAS lib's in-memory portion. So just like your laptop, when you load something out from disk to memory, again, it's in your memory. Here, it'll just be in memory on the CAS server in this specific CAS lib. And the reason each CAS lib has its own in-memory portion and data source portion is because each CAS lib has access controls, right? Permission on who can access this CAS lib or those in-memory tables or those data files on disk. What you'll need to do when you use the CAS lib is take data from disk, just like you would with pandas and a read underscore method, and load it into memory. Same thing, but you're just doing it on the CAS server instead of doing it on your laptop. Once you load into memory, you process it, but again, it loads into memory and it distributes the data and you process it in parallel. So, what if I want to see what CAS libs do I have access to on this environment, this CAS server? So I'll run the CAS lib info action. So con is my CAS connection. CAS lib info is an action that says what CAS libs I have available. And I can quickly see I have about 8 CAS libs available. They're all path-based. Again, this is a simple demo image. Each CAS lib has a description about it, its path, and then some properties. The CAS user CAS lib is what I'll use here because it's my CAS lib. It's like your My Documents folder, right? Only I can access this location because it's based off my username, in this case, student. So I'll create a variable called ds_CAS lib that just references the CAS user CAS lib. One quick note, you don't have to type student. You can just type CAS user. Now, I'm looking at the CAS user CAS lib, so I've created my variable. What if I want to see, well, what files are in there? What data source files are in that location, that folder in this case? Well, con.fileinfo, and then just say CAS lib equals, in our case, CAS user by just using that string variable. We'll run this. And let's go. I forgot to run my first one. Let's go back, and there we go. So I have, in this case, 5 files on disk, some cars files that I've just saved here just to have them. And then I have this TSA claims raw.csv file that I got from the SAS documentation page above. And that's the file we'll be using. So these are the files on disk in that location that only I can access. So next, what if I want to see what in-memory tables I have, or what CAS tables is a term I'll use. What CAS tables do I have? Well, then I'll use the table info action and then specify the CAS user CASLib. And here I can quickly see I have no tables in memory. So that's like me telling you, hey, you don't have any data frames, right? I don't have any CAS tables, you don't have any data frames. But this time, again, we're just pointing to the CAS server. So what we need to do is load data from disk into memory. In Pandas, you'd use read underscore something, load it into a data frame. We'll do the same thing here. Now, when you're loading data into memory, into CAS, there's really two ways to do it, or two locations is the best way to put it here. You have what's called server-side files. And the server-side files means that there's a CASLib pointing to that location. The CAS server knows about that location, is already pointing to it, so you can just reference it using this CASLib name. And then depending on what the server-side location is, you just load it into memory. With the specified permissions, so if you have the permissions, you can also load what's called a client-side file, which means the file lives on your laptop. So I have a CSV file on my laptop that I need to load to the CAS server. So those are my client-side files. They're on my client machine. I need to load them to the CAS server. And what we actually did earlier when we loaded the TSA data from the website to the CAS server, we actually did a client-side load. We took the data from the website, took the CSV file, loaded it to the CAS server, and then saved it as a CSV file in the CAS server. So we actually did a client-side load over there, but typically you'll be using server-side loads, and that's what we'll do in this demonstration. So let's load a server-side file into memory. And again, in Pandas, you use a read underscore method to do that. Well, here in CAS, you need to use the load table action. And a load table action will load any file type into memory. So here we want to load a CSV file type into memory. It'll also load Parquet files, which we'll actually see later. If you have a data source that's a database, you'll use load table as well. So it's going to load them all. So we'll use load table. The path is the file name, in this case TSA claims raw.csv, which we saw earlier. And then the CASLib is the CAS user CASLib. So this is the input data. Load this file from disk here. And to load it into memory, and this CAS out parameter says call the new CAS table or in-memory table, TSA claims bad, put it in this in-memory location, which is the CAS user CASLib, and replace it if it's already there. So I got a quick note. It loaded the file into memory. Here is the CASLib it went to. Here's the table name. And then here's the reference to that table. So it loaded it into memory for us. So we're ready to go, right? We essentially almost did what a read underscore method does on your client machine in Pandas. So now let's run table info to see if we have a CAS table available, right? An in-memory table in the CAS server, and we do. And there it is. How many rows, how many columns, and some additional information that you can kind of scroll around and look at. So I now have a CAS table, right? An in-memory table. It's distributed across all of the, in this case, CPUs and threads we're using. Now to use that CAS table, right, to start processing it, you need to make a reference to it. So I'll call my reference claims underscore bad, and then I'll say con my connection object, CAS table, and then the CAS table method, I specify the CAS table name, so TSA claims bad, which is just this table in memory. And it's in this location, CASLib equals CAS user, which is my variable that points to CAS user. And that's it. This is not case sensitive here. So this is all uppercase or lowercase. It doesn't matter. It's not case sensitive. So now I'll execute this and look at the value of claims bad. And it's actually not showing me a table of information. All claims bad is it's pointing to data. So I'm here on my laptop and I'm pointing to data in the CAS server, which in this case is just in the cloud somewhere. So my laptop is pointing to the CAS server, and it's pointing, in this case, to this table. If I look at the type of that object, it's a CAS table object, which again, we're going to treat CAS tables pretty much like data frames, but they are living on the CAS server, and this object just points to it. Now, let me show you can use a lot of your Pandas API methods on a CAS table through the swap package. So I'll say claims underscore bad dot shape. And it returns a tuple of how many rows and columns are in the table, just like I'd expect in Pandas. Next, I'll use the table details action, and it'll just give me detailed information about the CAS table. This is an action, so it's not a Pandas method. And you can see how many blocks this table is in, its rows, its data size, its variable data size, etc. So we can see some additional information about that CAS table. And I just wanted to show you this one. If I want to print information about the CAS table, I'll use the Pandas API info method here, verbose equals true, to get all the information. And again, it tells me it's pointing to this table, and it's returning exactly what I'd expect if I use Pandas. Now, one thing I want to point out here is, as a subject matter expert in TSA data, I quickly noticed this claims number column, there's missing values there. And that just kind of put a light in my head that said, okay, something's going on here when I loaded this into memory. So I'll have to figure this out in a second. And then I can see that everything has missing values and it's type. Now, why is claim number missing? So something was wrong. So I went to the CSV file and then I looked and I found something. And let me show you the image of what I found. This is the claim number, but some claim numbers have letters in them. So just to let you know, with a CSV file, the load table action scans 20 rows of a column and says, this is a number or this is a character. So it just decides from 20 rows. In our case, it's probably not good. I probably want to make this column character. So lastly, let me preview the table. So I'll say claims underscore bad, my CAS table object dot head. And here's a quick preview. So again, claim number is a number. So we already said we're going to change that. And then date received and incident date are numbers here. And these are SAS date values. So this is a number based off January 1st, 1960. So these are the amount of days after that. So one thing I'm going to do is when I import the CSV file, I'll apply a SAS format so I can have a human readable date, not a SAS date value. So we're going to fix those as well. So we've all been through this process before. You loaded data, it didn't load correctly, you have to go back and modify some things, and that's what we're going to do here. So let's reload the CSV file as a CAS table and fix the issues. So again, load table, specify the CSV file on disk. CAS out is naming the new one TSA claims raw, putting it in the CAS user CAS lib, and replacing it if it's already there. I'm leaving the original one there just to show you something later on. Now we need to change some of our options. So the import options parameter, and then I give it a dictionary, just like I did with CAS out. So I'll give it a dictionary of essentially options or sub options here. So the file type is CSV. The guess row option here will say, okay, the default is 20, but I'm going to ask it to scan 220,000 rows to determine the column data type and size. And then I'll use this vars option here and then specify, in this case, a list of dictionaries where incident date, and then that is going to have a format of MMDDYY, which is a SAS format. Date received is going to have another SAS format, and then close them out will have another SAS format. So I'm just going to add some formats to some of the columns. So after I run that, it looked like it loaded successfully. I'll run or execute my table info action. And now I have two in-memory tables. The bad one that I originally did, and now I have my raw one. Again, pretty much same information. So let's reference the new one. So claims underscore raw equals con.cas table. Here is the table I'm referencing, TSA claims raw, in the CAS user CAS lib, and then I'll just run the head method. And now this is looking better. So this is now my character column, so it's looking pretty good. My dates, I applied some dates to the SAS date value, so that looks nice. And then again, we can look through our data, and it's looking pretty good, but we'll have to explore this further. So let's explore it. I'm going to execute shape and info just real quick again, since we've already done these. Again, same amount of rows and columns. And now info looks better because claim number is not false, and that's what I expect. So again, as a subject matter expert, you'll know a little bit more about your data. In this case, we're pretending to be TSA experts. I'll use the dtypes attribute, again, just like you would in Pandas, and again, will just give me some attributes about each column. For a CAS table, I typically won't use dtypes. What I like to use is column info. It's an action. And CAS tables have additional column information, so you can add labels to a column. So when you're using it in, say, like another application like Visual Analytics, it'll use the label in all the dashboarding visualizations, and it'll also just store a label with the actual column name. So we can do that. And then columns have lengths and formats as well. And we applied those formats earlier when we loaded that CSV file into memory. So we got started, we loaded files into memory, we referenced these CAS tables, and we ran a few actions and methods. but you really have to have a pretty good understanding of the objects that you're using. And that's really important here because sometimes your objects are pointing to CAS tables with, a gigabyte, 10 gigabytes, a terabyte of data. And sometimes you'll have an object pointing to a data frame. And you really have to understand that. So let's talk about some common objects here in the swap package. So in the swap package, if you ever use, say, a Pandas API method from the swap package on an object or a CAS table object, it'll get sent to the CAS server. The CAS server will process that data and then send something back based on the method you used. Sometimes it'll send a Pandas series or a Pandas data frame. Sometimes it'll send a SAS data frame or another CAS column or CAS table object. So these Pandas API methods in the swap package can send something back to you. What it is depends on the method you use. A CAS action on an object will always send what's called a CAS results object back to the client. So I'll execute a CAS action, it'll get sent to the CAS server will do something, and then send back an object to the client. In this case, the object is a CAS results object. So now you're thinking, well, what is, in this case, a SAS data frame? What's a CAS results object? Well, let's take a look. Now remember, if you see a CAS table object or a CAS column object, like we saw earlier, those are just client-side references. So from my laptop, I'm referencing a table in the CAS server. So it's just a reference, right? It's not actually storing the table itself on my laptop. It's just pointing to the table in the CAS server. If you see a SAS data frame object, that is simply a subclass to a Pandas data frame that lives on your client. So it lives on your laptop. So if you have a SAS data frame, it's the same thing essentially as a Pandas data frame. It has a couple additional attributes and methods, but in the end, you would just treat it as a data frame, a Pandas data frame. And if you see a CAS results object, that's like a Python dictionary that'll contain keys and values. Sometimes the values are a bunch of data frames, sometimes a single data frame, sometimes keys and lists. So we'll play around with that. But a CAS results object, again, lives on your client and it's just a Python dictionary with keys and values. So earlier we referenced claims_raw to our CAS table. And again, we'll look at its type. It is a CAS table object. If I look at its value, it's just pointing to a table in the CAS server. To process a CAS table, you must execute an action or method on that object. So in this case, I'll execute the head method, and it does exactly what you'd think it would. It just returns 5 rows to your client. Now, some methods will add parameters to the CAS table object. So let's just look at a quick example. If I say claims_raw.query and then the column disposition equals deny, right? Typically, if you've used Pandas before, you're just assuming your data frame will come back and it'll only have rows where disposition is deny. But when we execute this, it's adding this where parameter to the CAS table object. So now it's waiting for another action to then apply this parameter to only return, in this case, the rows where disposition is deny. You can also do this using bracket notation that you've probably done in Pandas before. So claims raw and then claims raw of disposition equals deny. Now this adds additional parameters to the object because we're using kind of this API through it. Yeah, you don't really have to know what's going on. Just know it's adding that essentially filter to the object and it's waiting to then execute that on the CAS server. So we haven't done anything to execute it yet. If I go back and look at my object, here I'm still pointing to the full CAS table. So let's apply a filter and the shape attribute. Here I have my CAS table object, claims raw. I'll use my swap query method to query the CAS table, and then I'll execute the shape attribute. So this should give me how many rows are in the deny disposition, and about 99,600. I could do the same thing with the bracket notation. So my bracket notation.shape, same answer. So those work pretty much similarly. Behind the scenes you saw earlier, they're doing something slightly different. If I execute claims_raw, it's still pointing to the original CAS table. So what I will do is use some Pandas API methods from the swap package on a CAS table object and see what it returns back to me. And then what else I'm going to do is turn on these two options, and this will show me what these Pandas API methods in the swap package are actually running behind the scenes. So what actions are they actually running? So we'll just turn those on. just out of curiosity, and I'll show you those. So here, claims underscore raw dot head, so CAS table dot head, store that in DF, and then display the type of DF and the value of DF. So here is what actually ran on the CAS server, the fetch action. It returned a data frame, a SAS data frame back to the client, and this is my SAS data frame. So DF is a SAS data frame that lives on your client. The shape attribute from the swap package returns a tuple, so type of claims underscore raw dot shape, which we've seen numerous times already. But this time we can see what is actually running or executing on the CAS server, which is the numRows action and the table info action. We can do the same thing with value counts, so CAS table, disposition is my CAS column, value counts is the swap value counts method, store this in VC, and then we'll display the type of VC and the value of VC. Right, and I want you to think for a second, what object do you think the value counts method will return? Okay, let's see. So it ran column info and freak, and it returned a pandas series. So it went to the CAS server, summarized all that data, and then sent back a series to the client, and I can do whatever I want with this series. And to prove it to you, I'll say vc.plot, and I'll just plot a bar chart. So it looks like most of the TSA claims are denied, and then the next is approved in full, but probably half of that deny column. So again, I sent executable methods to the CAS server. It processed my big data over there in parallel, and then returned smaller summarized results back to my client. Now let's execute some CAS actions from the swap package on a CAS table object. So claims underscore raw dot column info, store that in CI, and then display the type of CI and the value of CI. Notice because I have those trace options on, it's just telling me it just executed this on the CAS server. It returned a CAS results object, and here is my CAS results object. Now remember, I said a CAS results object is just a dictionary on your client. So look, up here we have the key, and then here we have the value, which is a data frame. And let me prove that to you. If I say ci.keys, so ci is my CAS results object, keys is my method, I have one key called column info, and we can see that here. So if I want that data frame within the column info key, well, I'll just use the CAS results object ci, use the key column info, and store that data frame in DF, and then display the type of DF and its value. So I got the data frame from the column info action, and there it is. And there's this data frame. And then once you get a SAS data frame, just treat it like a pandas data frame. It lives on your client. Pandas works with it. So I'll just say df.query. I want all columns where it type is varchar. And then again, give me all rows and just give me the column and type columns. Again, just using traditional pandas here. And then I got all my varchar columns from the column info action. That gave me a data frame on my client, and then I just filtered it. I'm going to turn off those trace options. Again, just wanted to show you that those exist, and if you're curious, you can see them. We don't need them. So we've explored our CAS table. We have a general idea of these objects. My one big piece of advice to you is when you're creating objects, just be very careful with how you name them. My naming convention is pretty straightforward. If I point to a CAS table, I'll just name it, claims underscore raw, claims underscore something, whatever that CAS table is. Anytime I have some sort of data frame, I do an underscore df or just df equals, kind of use that key term in there. And that helps me understand this is a CAS table object. This is a data frame on my client. So let's explore CAS table columns. And here I want to view the number of missing values in the CAS table, and I'll use the pandas API method. So claims raw.endMiss, I'll store that in endMiss underscore seer for series, because this will process in the CAS server, return a series to my client. I'll display the value and its type. And again, just to prove it to you, CAS table endMiss returns a pandas series, and there it is. Since I have a pandas series, do whatever I would normally do with it. So endMiss seer, I'm going to sort the values and I'll plot it just to plot the number of missing values in each column. Close amount has the most missing. Claim number does not have any missings, which we saw earlier. And pretty much all my other columns have missing values. If I want to view the number of distinct values in a column, again, just using the pandas API, just kind of keeping it pretty simple here. We have my CAS table. my CAS column, and then the nUnique method in the swap package, and I'll drop in a equals false. So this will count missing values as a unique value. And this will give me that the column claim type has 18 distinct values, including a missing. Well, what if I want to see a list of those? Claims raw, claim type, unique, and then the unique will return, I believe, an array back to the client. Once I get the array on the client, I will then make that a list, and then I will execute that. And we can see the list of unique values in the claim type column. And let me point out, we have a missing, we have a dash, so those are something I need to fix later on. We have some issues here where passenger property loss essentially has two values, and one of them is a typo. Same thing here, property damage, personal injury. We have a property loss. So there's some things I want to do to consolidate this column and clean it up, which we'll do later. But I can see there's some issues in here. Now, if you want to view the number of distinct and missing values in a column using an action, which again will work, if we use the distinct action, which is a pretty powerful action, it'll get you the number of distinct and missing values in a column. So claims raw distinct, store that in CR for CAS results, and then display the type of CR in CR. And I'm just proving to you that this is going to return a CAS results object, which it does. The key is distinct, and it returns a data frame with the number of distinct values and the number of missing values in each column. Now, since I have a CAS results object that lives on my client, that looks like a data frame, so let's pull that data frame and then work with it. So distinct underscore df, and then the CAS results object key distinct to get the data frame. And again, just to prove to you that I got it, distinct underscore df is now a data frame, and it stores this value. So I'm not even using CAS anymore. CAS is done. CAS counted all that information, send it back to me, and I'm done using it. I'm using my Python client here. And once I get that, I want to calculate the percentage of distinct values in each column. So I will get the number of rows in a CAS table, just using the shape attribute on a CAS table. And then I'll get my data frame. I'll assign a new column called PCT distinct, and it'll take the number of distinct values divided by the number of rows that I got up here. So this is all CAS table, right? So this is processing CAS, returning the number of rows, storing it on my client. And this here is all running on my client. I'm not even using CAS down here. So when I run this, I can see the percentage of distinct values in each column, and I can see claim number is not 100% distinct. So there could be something going on there. So let's explore the categorical columns. And again, I'll use the value counts pandas API method from the swap package. So we will specify, store it in a variable called sites underscore seer. Value counts returns a series, and it does the same thing in SWAT. Claims raw is the CAS table, claims site is the CAS column. Value counts, normalize is true, drop NA, those are just traditional options. And again, we'll look, and it looks like a series that CAS server processed, value counts, return a series to my client. And once I get the series on my client, I can again use traditional Python packages. So here I'll just simply plot that series. And I can see check baggage is typically where the issues occur. Then the checkpoint, so I'm guessing that's the checkpoint as you walk in through security. Other, and then not provided, motor vehicle, etc. So most of my issues occur in check baggage. Now, if you want to kind of move and go into the CAS action world, we can do something similar. Now, remember, with value counts, it returns a single series. So if I wanted to run this each time, I would have to do value counts in some sort of loop on each column. The simple.freq action is pretty powerful. So what I'm going to do is specify the columns I want to analyze in this list, and then create a variable CR equals claims underscore raw.freq. So this is my simple.freq action. And I want to use this list of columns up here, include the missing values because I'm curious, and then I'll display the type of CR and the value of CR. And I'm doing this last part just again to prove to you that CAS actions return CAS results objects. So it returned a CAS results object, and here it is. It's a data frame with 154 rows. So what the freq action does is it just consolidates the frequency of each of those columns in a single data frame. And once you get that, you can loop over that. So all the processing occurred once on the CAS server, return your data frame, and then you can do what you want with this data frame. I'm going to simply access it. So CR frequency, the freq df, and then just view 50 rows of it. And just to show you that the column claim type we have character value, and then, so that's the raw value, and if there's a format applied to it, which there isn't, is over here, and then the frequency values for claim type, and then there's claim site, disposition, etc., all the columns I specified. We already saw that there's issues in claim type. Claim site has missing in a dash and not provided. Disposition has a missing in a dash and not provided. It also has these closed space canceled, closed, and there's no space. So there's some typos in here. Closed contractor claim, and then this one's missing a C, and there's 73 of those. So I'm noticing some issues in my data that I will need to fix. Another action is the freak tab action. The freak tab action is not loaded by default, so you will have to load this action set. So to load an action set, it's con.load action set, and then just specify the action set name, and I've loaded the action set. It's very similar to simple.freak, but this will give us way more information in our results. So we will execute the freak tab action, so claims raw.freak tab. You have to use the tabulate parameter and specify a list of columns, which we have stored in this variable. I want the order and frequency descending, and I want it to include missing values. So we'll view this, and this is what freak tab returns to us. It gives us the number of obs, so our key and our value, our level info, so the level info of each column I specified, and then it'll give me a one-way frequency of each column. So this one is claim type. We got the frequency, its values, its percent, its cumulative frequency, and its cumulative percent. So freak tab gives us much more information, and you can pretty much get that from the simple.freak versus the freak tab, right? So the simple name is just very simple. This one gives us additional info. Claim site, again, all the issues we talked about earlier. Disposition, again, some issues in here we need to fix. State name has some missings, and they're all uppercase. It also looks like it's including territories as well, since there's 57, I believe. And then same thing here. We have missings, and then we have 57 or 56 here. So we are including territories. And then it gives you some timing info. But remember, a CAS results object, an action goes to the CAS server, does its summarization or analyzing, and then returns something back to you. In this case, it returned this CAS results object with all of these keys. So once I have these keys in this CAS results object, I can just work with this like I would a data frame. So I'm going to specify the table 1.one-way freaks here, and then sort the values, and then plot them. And this is all just using pandas. Nothing special here. So the majority of these claims are passenger property loss, and then after that is damage. There are some interesting ones here. Bus terminal, there's a wrongful death. There's some missed flight issues. So there's some interesting ones here that we can explore later. And now a big thing is working with dates. So I'm curious if the incident date and the receive date are accurate. So let me just pull the years out and just scan and say, all right, what distinct years am I getting? And how many rows of data are for each year? So I'll use the CAS table object. I'll specify the column date received. I'll use DT to access the date time properties. I'll just use year to get the year of the date time value. I'll use value counts. So just to show you, all of this occurs on the CAS server. It's going to occur on the CAS server, it's going to process on the CAS server, and it's going to return a series back to the client. Once I get the series, I'm applying this sort_index method. So it starts in 2002, that's looking good, and then all of a sudden, data goes from 2020, 2025, all the way to year 3005. So something's going on here. So again, something I need to fix and deal with later. And I'll do the same thing for incident date. So everything's the same except I change the column. It starts in 96, it goes to 2000, 2001. So I have earlier data for some reason, and then it goes to 2018. So it accidentally pulled 2018 data. So again, I have to fix something. Next, I'll explore numeric columns, and I'll just use the common describe method on a CAS table, and it gets what I expect. Now, the issue here is date and incident date are SAS date values, which are just numbers. So these don't really mean much to me currently. So I don't care about those. I do care about close amount. So I'm curious, what was the amount the claim was being closed at? So minimum is 0. So a lot of the data, median's even 0. And then all of a sudden we get to $68. And then we get to $250,000 claim. So we are curious about this one, so we'll just save that for later, right? We'll remember this and we'll say which airport had this claim. I'm curious, what happened to this claim? But what I want to do now is create new columns and use the describe method to analyze those and explore those. So I'm going to create 3 columns on my CAS table object. I'll use the eval method to do it. You can use bracket notation too. I just like the eval method. I just personally really like it. So .eval date diff equals, so I'm going to create the date diff column equals date received minus incident date. One thing to be aware of is the string you add in here is essentially a SAS assignment statement. So you can use SAS common functions in here. Anything you can kind of do with a SAS assignment statement through like the data step you can do in here. So if you come from a specific Python background, this might be a little different for you. There's a lot of great documentation on the functions you can use. Here, .eval incident date is year of incident date. Actually, let me go back to this one. What I'm creating with this column is how many days till the claim was essentially filed or stored. So if the incident occurred today and then the claim was filed 3 days from now, there would be a difference of 3 days. So I want to see positive numbers for date difference. Incident year, I just want the year. Incident date received, I just want the year. We'll execute those. So let me look at that CAS table object now and notice it just added all of these parameters to it. By default, the in place equals option here is true, so it just default adds these to the object. Unlike the query parameter or the query method that we used earlier, it was in place equals false as the default. You can use this params attribute on the object just to take a look at the actual parameters. So the name specifies the CAS table, CASLib specifies the CAS user CASLib. Computed vars, all this does is it specifies the column metadata. So it's just saying, hey, I'm creating these 3 columns. And computed vars program is the actual expression it's using, if you're curious. I typically just don't really kind of pay mind to this. So now if I run the head method and I scroll to the right, there's date diff, there's incident year, and then there's the received year. So we have some values here, and if I go up to the top, let's see. So these are all looking pretty good. So what I want to do next is just use describe on the 3 new columns I created. So again, the object stored all the expressions it needed. I only want those columns. I want to describe those. So if I look at date diff, one thing I notice is there's a minimum value of negative 1800 or so. So what that's telling me is it's telling me that a claim happened and then 1800 days later the incident happened. So that doesn't make any sense. So I have some negative values and then I have a claim. So the incident occurred today, for example, and the claim came in 365,000 days later. So something's wrong with my dates, which we've already figured out earlier. And then incident and received year. Again, our min is off, our max is off, our max is off, but our min here is okay. So get a lot of fixing to do. Let's go back and look at our object. And again, it's storing all that information, so I'm happy with that. So I'll just use, in this case, I'll use an action to get the same information. I'll use the summary action. I'll specify inputs equals the call name, just a list of columns. And then subset specifies the descriptive statistics I want. So if I just run this, I'll get the min, the max, the number, and the number of missing. And again, very similar to what we did earlier. If you are curious, if you remove all these, you can see the summary action gives us a lot more information if you are curious. But we'll leave this as is. All right, so we've did our exploration, right? I'm kind of running through this entire process. We've noticed some issues. We've kind of documented those issues. So now let's begin starting to prepare our data. The first thing I'm going to do is remove any entirely duplicate rows. So if you've used like pandas before, this is very similar to the drop_duplicates method. So we're just going to remove entirely duplicate rows. To do that, you have to use the deduplication action set. So I loaded that. and then claims underscore dupes, and then we'll say con.cas table, and we'll reference that raw data. Because remember earlier we added all those parameters to it. So I just want to start this from scratch and re-reference that raw table, that cas table, excuse me. And I'm calling this claims underscore dupes. Now, I need to give my action a list of columns to use to determine duplicate rows. I just want the entire all columns. So I will create a call names variable again, claims dupe.columns to list. So take my cas table, get the column names, make it a list, and then store that. So here are all the columns. So now I need to add this group by parameter to the cas table, and I'll group by all of those columns, and then just to show you it was added, we have the name of the table, the cas lib, and the group by. This will allow me to then use the action just to remove all duplicate rows based on every column. So it'll look at every column and determine duplicate rows. So the action is the deduplicate action from the deduplication action set. I know it's a mouthful. But we'll deduplicate the data using this cas table object, which is using this information. I'll create a new table called claims underscore no underscore dupe. I'll say I want to see the duplicate row. So if say there's 2 rows in that data that are exactly the same, it'll just remove one of them and put it in this table. And then you need this option to say to remove duplicate rows. There are other ways to get unique values and stuff. So this action can do a lot more, but we just want to remove duplicate rows. I can quickly see it pulled all the data. It only kept this many rows, 220,850, and it found 5 duplicates. If I go to table info again, so the action to look at all my available cas tables, I now have 4 tables in memory on the cas server: bad, raw, no dupe, and claims. So these, if I want, I can investigate them further and figure out why is there duplicate rows. I don't particularly mind at this point. I'm just going to avoid that one, and we'll focus on this table, which is the table without duplicates. So let's create the final cas table. So as a subject matter expert, I came up with all these rules that I want to do on the final cas table. State should always be in uppercase. State name should be in proper case. Claim site, I'm going to fix anything that was missing, not provided, or a dash to just the category value unknown. Same thing with disposition, and fix those typos in disposition, like closed space canceled and the Lowe's colon space contractor claim, and I just want to fix all those. Claim type had a ton of issues, all those missing issues, any typos. And anytime I saw 2 values, like passenger property loss / something, I'm just going to pull the first value. I'll create a new column named date issues. And now, this step 6, there's a lot you could do here. You could remove data issues, right? I'm just going to keep the data issues in the data, and I'm just going to create an identifier. If it's a data issue, I'll just notify myself, hey, there's a data issue in this row. If it's not, I'll say it's a valid date. So that's all I'm doing here. So a missing value for incident date and date received. If there's an incident date or date received value out of the predefined range of 2002 and 2017, or an incident date value that occurs after the date is received. And again, that is just saying someone filed a claim today and then the incident occurs 3 days later. That doesn't make sense. So I'm going to use a conditional and then just create a new column that identifies if it's an issue or not. I'll create my date diff column to identify how long the claim took to be received. So just date received minus incident date, which we saw earlier. And then I want to create 2 year columns for the incident year and the received year. So I'll reference the deduplicated cas table. Again, con.cas table, claims no dupe. Here I uppercased it just to show you it'll work. And I'm going to call this claims prep. Again, just a simple reference to that cas table. And then I'll just run head real quick, make sure it's looking like the one I want, and it is. So now we need to break this into 2 parts. So cas tables have more structure than say like a data frame. With a data frame, you can modify the column type. You can change a lot to it right within the data frame. With a cas table, you can't change column types. You can't change the column length to an existing column. You can create a new column and do what you need to do. It's just very structured. So when you're updating rows, you need a specific action to do this. And just one thing to remember, if you're sharing this table in a public cas lib or some cas lib a bunch of you can access and you're updating a table in place, just remember anyone can access a global table. So if you're updating a table in place, you could be fixing it or hurting someone else's table. So you just got to remember that when we're doing this. So we're going to update rows in a CAS table. Modifying columns using the method I'm using here requires Sass functions. So we're going to use Sass functions. You can click the link and kind of look at all the Sass functions. You cannot update a row in place and create calculated columns in the same step. Just make you aware of that. So here I'm going to update columns, and let me just show you my technique for it. I like to compartmentalize my code. So to do this, I'm creating a variable called upcase state, and it's just using the expression upcase function and then state. So I know this is going to update my state column. My state name column, I'm going to prop case that. So prop case state name, and again, it's just a string that I will utilize in an action. Now, fixed claim site, I will just go over this one. The rest uses the same logic, so you can kind of dive through that on your own. But the if C function is just using essentially if then. C says return a character. If you had N, it'll return a number. So I want to return a character. And if claim site is in a dash, a missing, or a not provided, so if it's any of those are true, return unknown. Otherwise, return the original value of claim site. So you can see unknown here is in single quotes because it's returning a character, literal. And then here, claim site is just pointing to that column. But again, this is enclosed in triple quotations, which allows me to nest a string on multiple lines in Python. The rest are doing the same thing, if C, if C, if C. So they're just kind of using the conditional nested within each other. So I won't go through all the details for those. Feel free to dive in there. So we're using a conditional. And then what we do is after we created all these variables with the string for the expressions we want, claims prep is the CAS table, the update action, and then I use the set parameter, and now I give it a list of dictionaries. Each dictionary is the column I want to update. So here, this dictionary says var, so variable state, update that, and for the value of state, use this variable, which is really just this string at the top, upcase state. Same thing here, and so on and so forth. So a list of dictionaries, each dictionary is the column I want to update. So let me execute this code. And it says all the rows were updated because I either changed the value or returned the original value. Now, there are a variety of ways to do this. You could use the update action for each individual column and then use a where parameter to kind of filter and specify only the rows you want to update, which I think might be a little bit more efficient. For the sake of simplicity, I just did it this way. Now, after I updated my columns, updated my rows, I want to confirm I did it correctly. So I'm going to create a list, state name. So these are all the columns I updated in just a list, a Python list. For call and call names, I want to get the unique values. Here's my CAS table. It'll pull one element of the list as it loops through. I want the unique values, and I'm just going to use an F string to print them. I just want a quick look at the unique values of each column. Now here state still has missing, so I just ignored that for now. You could probably change that. But these are all uppercase. These are all proper case. And then claim site, we cleaned up. Bus station, baggage, checkpoint, vehicles, other, pre-check, and unknown. The missing values are gone. The dashes are gone. Disposition, approved in full, close canceled, close contractor claim. So we fixed all of those. And then the unknowns, and then same thing here. We fix all the values here based on our subject matter expertise of the data. So we updated the values. We checked that my logic was correct. There was a lot of if C's and nesting, so I wanted to make sure that was good. So let's create the final CAS table with the calculated columns. So let's create the new columns. Using the same logic, but this time I need an assignment statement in here. So create date issues equals, so it'll create the column date issues, if C, kind of the same thing I did before. And here it's just a bunch of tests. If the date is this or missing, or the year is before this or after this, that column or that row will get a value of needs review. Otherwise, it'll get a value of valid date. I could do a 0 or a 1 if I wanted to, right? 0 means it's fine, 1 means it's not. I just tried to make it a little bit clearer of what I'm doing here. Create a new column called date diff, which is date received minus incident date. I'll create a new column called received year, just the year of date received, and then an incident year, which is year of incident year. Again, using a Sass function. The hardest part for me is you're putting these in a string, which is a little confusing at first. And now I've created all those variables. I will use the eval method, and then I will chain that to the CAS table object. So this takes a little bit of work getting used to, but I think it cleans up your code. And I've read some books on this, and it's just really good technique that I am stealing from some of the books and videos I've watched online for using pandas. But here's my CAS table object. Here is the eval method. Here is the assignment statement it's going to use that I created above. And if you use inplace equals false, it'll append the parameters to this object, and it'll return the CAS table object back to me. By default, it's inplace equals true, which I think returns a none type. But if I use false, it'll just continue to return the CAS table object, and I'll just continue appending this eval method to it for each column I would like to create. Then the copy table action says whatever you added to this CAS table object, all of those parameters are just being added to this object. Take that and create a copy of that CAS table here, and then name it TSA claims final in this CASLib and replace it if it's already there. So let me execute this code. I created the final table, and then let me just run table info again. And now I have 5 tables in memory. Now, if these tables were huge, it's probably good practice to start deleting them if you don't need them. Like I'm not going to use bad or raw anymore. So you could go back and delete them. I'm not going to. I wanted to show you something in this demonstration. And these aren't big enough to really worry about. It's just small training data. So now let me reference that new CAS table, TSA claims final, in the CAS user CASLib. Just look at it. Date diff, received year, incident year. These are looking good. Here's an issue already. And then one thing to note, anytime you run the head method or the fetch action, remember the data is broken up into parts on each thread and each CPU. So you're not guaranteed order. So every time I run the head method, I won't be guaranteed the same 5 rows in this example. So just be aware of that. If you want to guarantee rows, you have to sort the data and then bring it back. So just something to think about. So I've done a lot of work, right? I want to confirm everything I've done is correct. So here I'll look at the received year and incident year, and then I'll just loop over those. And I just want a list of each year where the date issue is a valid date. So I'm just kind of confirming that my logic, where I was indicating valid date versus needs review, I'll take the CAS table. I'll query that CAS table for only rows with valid date. Again, I'll pull all rows and only the column through this loop. Create a unique, I think this will return an array back to my client, and then this will make a list from that, and then I'll just print that information. And it'll just run the loop, and what I'm checking here is making sure my valid dates go from 2002 to 2017, which they do. Again, I can do some more tests on all the new calculated columns I created, but we'll end that here. So now, let's look at this object, and this is good practice. Just make sure you don't accidentally add parameters to an object that you don't want, like a where or a calculated column or grouping. So again, we're just simply referencing the CAS table in the CAS server. So now let's begin answering some business questions. So where did the claim occur with the max close amount value of $250,000? Remember, we saw that earlier. So what I'm going to do here, if you want, the solution is down here, which I'll go over in a second. But if you want, pause the video. Pause the video and try to solve this with what you've learned already. So I'll give you a second to do that, and then I'll go over it. All right, I'm back. So if you paused it, great. You tried it. Hopefully you figured it out. The solutions are down here if you just wanted to look at it real quick, but I'll just expand the solution. I did it this way. I stored the max close amount value, so claims final is my CAS table. Close amount is my column. Max will get the max value, and I stored that here. And then I just used my CAS table object, my query method, my f string. Again, it's just a Python f string. So if you're not familiar, you can kind of look those up. And all that'll do is take the value of this here and enclose it in my string. So close amount equals 25000. And then I want the head method. Now the head method, again, is only returning 5 rows from my CAS table. So for example, if there was 30 claims with $250,000, I would only see 5 of them. In this case, I'm confident that there's only one. I know the data well enough, but just be aware, head will only return the 5 rows. You could get the total number of rows where this is true and then put that number here. It's kind of up to you, but in this case, we'll run this. All this processing occurred on the CAS server and then sent back one row of data to me on my client. So this person had a $250,000 close amount claim. It was denied, and this occurred in Las Vegas. So pretty interesting. It was a checked bag, so it was just a curious one. So that's a pretty interesting one to look at. Another one was, what airports did the wrongful death claim types occur? So in the claim types, I saw wrongful death, and now I'm curious about those. So again, what airports did the wrongful death claim types occur? So again, if you want to try to solve this on your own, click the pause button. I'll wait a few seconds. All right, I'm back. So let's go over this one. We'll expand the solution. I have claims final as my CAS table object. I'll just use my query method and say claim type equals wrongful death. The key to this is the original string will hold claim type equals, and then my constant or my string literal will need to be in the opposite set of quotes. So in this case, double quotes. So just be aware of that. If I didn't use these quotes, it'll think it's a variable or a column name. So just be aware of that. And then again, the same issue with head. There was 10, 20, 30 rows coming back to me. I'd only see 5 of them. So you can kind of count the number of those if you want. And there's some other ways to do it, which we won't get into here. So here I get 4 rows, and then we have the wrongful death. It occurred at the headquarters, a motor vehicle, and then 2 at Jackson International, but they occurred on the same date. So I'm not sure if it's a duplicate claim or what's going on there. But one thing I do notice is the date received. One was in February 15, 2012, and then another claim. So it could be the same one. I don't know. It's something we can investigate further. So here, same process. If you want to try to solve this, pause the video. How many claims had date issues? So again, pause the video if you want to try this on your own. Solution is below. All right. Let's expand. And this is a very simple one. CAS table object, the column date issues, and then the value counts method. And then if I execute this, over 4,000 claims had some date issues. Okay. So next, this one's a little bit trickier. So we want to create a bar chart of how many incidents occurred in each year. So the incident column occurred in each year for claims with valid dates only. So that's what we want to solve. Use the incident year column. I guess you could use the other column as well, the column we created, but my hint says use the incident year column. So I'll give you a second. All right, so if you pause the video, good try. Let's go over it. I did this, again, there's a variety of ways to solve these, but my CAS table object, my query method to search for all valid dates, my incident year column, and then my value counts method on that. So this all is occurring on the CAS server. So again, I'm just chaining my methods. Again, there's some great books out there on this technique that I've been reading that I really like. So I'm chaining these methods together. This is all occurring on the CAS server, and then it's returning a series back to me on my client. And then all this processing, the sort, index, and plot is occurring on my client. We'll run all this code. So my guess from looking at this data is 2002, we don't have the full scope of data. That's most likely what's happening here. That's just my guess. And then we can see claims are going down generally. So pretty interesting. So this again is a little bit more intermediate to advanced. What is the total close amount for claims approved in full by each claim site? We want to sort that in descending order. So again, what is the total close amount for claims approved in full by each claim site, sorted in descending order? So okay, I'll give you a second. This one's a little tougher. My hint is there is a group by method in the swap package that works similarly to the pandas group by method. So that is my hint to you. I will give you a second. Pause the video. All right, let's go over this one. This one's, again, a little trickier. I did it in a different way. I added my filter at the top, so filter by approve in full. And then I have my CAS table, my query method, and with my F string. In my F string, I want this string here, but I need this surrounded in double quotes, right? The opposite set of quotes. I'll group everything by claim site. I'll return all rows with the close amount only, and then I will sum those. So this all up here occurs on the CAS server. It's getting the CAS table, it's filtering it, it's grouping it, it's getting all rows and the close amount column, and then it's summing the close amount column for each of these groups. And then I will just chain this method sort values at the bottom. I have my claim site and the total close amount for each. So check baggage, which from our analysis seems like that would be where the most money is. All right, and then the last one, if you have SQL knowledge, I think it'll be pretty easy for you to solve. But if you don't, we're using SQL here. So I want you to find what are the top 10 airports with the total number of claims in review. Use SQL to solve this question. And your hint is load the Fed SQL action set and use the exec direct CAS action. And the exec direct CAS action just executes SQL code on the CAS server. So what are the top 10 airports with the total number of claims in review? All right. So if you want, pause the video. All right, you're back. So let's take a look. I'll load the Fed SQL action set. I'll write my query here. So my query is just a string. So query claims in review amount. Use my Python triple quotes. And then just as SQL query, nothing special here. Select airport name, count as total claims in review from the CASuser.tsa_claims final table, where upcase disposition in review, I just upcased it. I know the values were okay. We've explored it. We've fixed things, but I just want to show you can do it. We'll group by airport names. We'll order by the total claims in review in descending order. And I only want to see the 10 airports. Once I have my query, con exec direct, query equals, and then my query. And again, I could just type the query in there if I wanted to. I like to do it separately. Run the code. Looks like the Los Angeles International Airport with total claims in review. Okay, and you can continue on and practice and learn. But now, just like in Python, you have a data frame, it's in memory. Well, what if you want to save it back to disk? And pandas, you'd say like 2_ something, and it would save the data frame back to disk. And we have to do something similar here because we currently only have an in-memory table that's finalized. So if I want to get this nice, clean final table, I would have to rerun this entire notebook, which I don't want to do. So what I will do is look at my object, again, claims_final, and it's just pointing to the entire CAS table. And what I want to do is save it in 3 different file formats on disk. Now, would I do this typically? No, I won't save it to 3 separate file formats. I just want to show you how easy it is to do it. So we have our CAS table. We want to save that as a CSV file. So claims_final.csv, and put that in this location, which is that folder path for the CAS user CAS lab. If I want to save it as a SAS HDAT file, same thing, just specify SAS HDAT. SAS HDAT is called a memory mapped file. It takes the CAS table, the in-memory table, and just saves really that memory copy back to disk. So what that allows you to do is if your table's huge, that'll load into memory much faster because it really knows exactly what to do. And then we'll just save it as a Parquet file, right? A compressed file as well. So save it in 3 different ways. I'll just quickly execute all 3 of them. That worked. CSV, SAS HDAT, and then Parquet. And if I ran the file info action, I can now see the new files I created. Claims final, claims final, claims final. All right. So again, I did this because I don't want to have to run this entire notebook again to get this final table. I just want to save it. So I know we're nearing the end. So let's look at the table info again. And we want to talk about CAS table scope because this is extremely important. And when I first learned this, I got a little confused. So this part's extremely important. When you load a table into memory, it gives it what's called scope. And that's either session or global scope. So global 0 means it's session scope. And we can see that here in the table info action. So let's talk about that. When global equals 0, that's a session scope table, and that's the default when I load something into memory. And that's what I expect it to be, is it's the default is global equals 0. And that means it's only accessible to this connection to CAS. Remember we saw earlier a connection ID? Only this connection to CAS knows about that table. That's where it was created. It's visible only to the user who created it. And once I disconnect from CAS, it'll clear from memory. And it's just managing its memory for me, just like Python. I load data into memory, read_CSV, I get the data frame, I do what I want to do. I close out of Python, it releases the memory for the data frame. Kind of the same idea here. The other issue is when it's 0, you can't share it with other applications like Visual Analytics either. So if it's a session scope, only this session has it. Global equals 1 identifies its global scope. It's visible across all CAS sessions. So any CAS session that can access that location, that CAS lib, can get to that table. Any other SAS Viya application like Visual Analytics that wants to create a dashboard can get that table. The admin controls access to each CAS lib, right? So I probably don't have access to every CAS lib available in SAS Viya. I probably have a select few, and same with you. The nice thing about global equals 1 is if I promote a table and I close out and I leave and 3 days later I come back, that table will still be living in memory. It'll have found a home and just living in memory. And then just a quick tidbit, if you create your own CAS lib, which we didn't do here, if you create your own CAS lib, a CAS lib has scope as well, which is either temporary or permanent, so session or global. If you have a new CAS lib you've created and it's session scope, so temporary, and you try to promote a table in it to global, it won't work, and it'll tell you what's happening. So just if you ever run into that, it's because your CAS lib is only session scope. So let me terminate my connection. Let me just go back real quick. We see we have 5 tables in memory on the CAS server. They're all zeros. So to terminate your connection to CAS, anytime you use CAS with your Python client, always connect, do what you need to do, and terminate, right? Always terminate your connection. There's a timeout that'll do it for you, but it's just good practice to release the resources. So I terminate my connection to CAS. I'll reconnect just using con equals swat.cas. I now have a new session ID. And then if I run table info, all my tables are gone. And that's probably what I'd expect it to do. If I go to file info, all my files on disk are still available. So with this information, I will load a table as global scope and I will load another table as session scope, and we will look at what happens. So I'll use con.loadTable. I'll use the Parquet file, claims_final.parquet, in the CAS user CAS lib, and then CAS out, just call it, claims session scope, CAS user CAS lib, replace if it's there. And then I'll load a table to global scope, the same file on disk. I'll call this TSA claims final, but then I'm going to use this option, promote true. So this, in this dictionary, promote is true. So promote this to global scope. I'll execute both of these and run table info. So both were loaded into memory, and then one of them has global scope, TSA claims final. So like I told you, a global scope table essentially has a home in memory. It just lives there. So if I terminate my connection to CAS, I reconnect to CAS, and then I run table info again, let's see which tables are dropped and which are left in memory. So the session scope table was dropped, but this table lives in memory. And lastly, just some benefits and considerations, or more considerations. Session scope is great for ad hoc analysis. Load it, do what you need to do, disconnect from CAS and let it clear itself. It conserves resources by clearing tables for you. And you don't mind loading that table into memory each time, right? It doesn't take too long. You're not too worried about it. The global scope is great for sharing tables across different applications like visual analytics, data mining and machine learning, etc., or other users. So as long as you promote a table in a CAS lib other users can access, they will see it. It helps you avoid reloading massive files into memory. If this table is just huge and it takes long and every morning you don't want to do this, load it into memory and you'll get a copy of that file from disk in memory at that time, and it'll just live in memory. And then one great feature of this is if we have a CAS lib called HR, I load data today into memory and I promote it, all of us in the HR analytics team will all be pulling that same in-memory table, so we will be getting the same results. And then lastly, I just want to kind of apply SAS Viya another application here with what we did. Again, I'm more of a programmer, but I do love creating visualizations and dashboards. So what I will do is I already promoted the table, which means Visual Analytics can access that data. And I just want to show you how you can put together Python in creating and analyzing data and preparing that data, and then with another tool like Visual Analytics. So since I promoted the table, all I need to do is go to SAS Viya. So I'll log in through SAS Drive, I'll click sign in. This is just, I have admin privileges, so this is some demo image, so we'll deny that. So now again, through my browser, I'm connecting to SAS Viya. Again, I'm on my laptop, connecting to Viya through the browser. Here are all the applications I have available. preparing, managing, building models, etc. So develop SAS code is the IDE. But I want to explore and visualize my data, so I will select this. So now it'll open up the Visual Analytics application. And then I'll just click Start with Data. And then now this is, again, a simple image, so I only have one table, but I could go to data sources, go in here, and pick and choose where I need data from. We've only been working with CAS user. Here are all my files, but this one, this lightning bolt here, is a CAS table. So I'll click this, and it'll allow me just to connect with it. Again, that's the one I loaded in Python over there. And now I have all my data here, and I can quickly create some visualization. So I'll do that. I'll just pick and choose real quick. We'll do the total close amount of everything. And then we can add, I don't know, the total date diff and so on. We can go here and add a time axis, which is the incident dates. Let's give us the frequencies. We can see all those date issues. So instead of that, I could go to filters real quick. We will filter out the date issues, the needs review. So we don't want needs review. And we can see we can quickly analyze our data, and this is by day. So pretty cool. Again, I can change this by month, by quarter, whatever I'd like. So again, here is Visual Analytics, using the combination of preparing the data, analyzing it in Python, exploring it over there, loading it to memory, and then using another tool. All right, so that is it. Let me terminate the CAS session or CAS connection. And I also have this script. If you want to run it, that's fine. And what it'll do is it will delete all the data source files we created, so the CSV, the SAS HDAT, Parquet file, and it'll delete that global scope table. So it's just a little script. If you just execute this cell, it'll ask you, do you want to delete these files? I'll just put a Y in there and press enter. So it deleted all those files we've worked with. It's up to you if you want to run it. And then I will just confirm everything was deleted. So no tables are in memory. And then here are the files I started with. I'll terminate my connection because I am done for the day. And then I'll just pinpoint you to some resources that I have available throughout this notebook. We have the fundamentals of the CAS server if you just want to learn more about the parallel processing architecture, the swap package, CAS actions, some great courses. There's a Python integration to fundamentals course, and then there's a machine learning with Python integration to SAS Viya course, so feel free to check those out. There also is a CASL course if you're interested in learning the CAS language. I found learning the CAS language was pretty easy coming from a little bit of a Python background, since it has different data types and it just has the actions within there. I have 2 blog series you can check out, Getting Started with Python, Integration to Viya, and a CAS Action blog series, which is introduces CAS Actions and what you can do with them, and then just a variety of other resources. Feel free to check those out. I've done other webinars and some communities. Here's the parallel data loading one I mentioned earlier when we started. So other than that, again, thank you so much for attending. My name is Peter Stiliadis. Please feel free to connect with me on LinkedIn anytime I do a video or a YouTube video, a presentation, a YouTube video, or release a blog post. I just post it on my LinkedIn page. If you connect with me, you'll get to see anytime I release anything new. Here's my information. Again, thank you for attending SAS Explore. All right, hope you have a nice day.